A reliable workstation rarely dies at a convenient time. When my 2016 desktop's motherboard finally shorted out, it took my entire video editing and testing workflow down with it. Replacing a 2016 machine creates a specific dilemma: buy a pre-built computer or build a custom one. Pre-built systems utilize locked configurations that often prevent you from reusing perfectly functional, high-end components you already own. The solution involves a hybrid hardware strategy. By salvaging the best of the old parts and centering them on the modern AMD Ryzen 7 9700X processor, you can rebuild a workstation on your own terms. Assembling a machine in 2025 is a calculated move. The hardware landscape has fractured since 2016, and a custom build offers the precision needed to navigate it. For decades, the computing world was dominated by a single partnership, Wintel. Windows software ran exclusively on Intel silicon, and the industry followed their lead. That dominance eroded as mobile processors took over. Chips based on the ARM architecture, a highly efficient design used in almost all smartphones, eventually beat Intel's mobile offerings and moved into flagship devices like the Microsoft Surface. The shift intensified when Apple abandoned Intel entirely to develop their own ARM-based Apple Silicon for the Mac lineup. Intel subsequently lost its lead in manufacturing precision to foundries like TSMC. TSMC, or Taiwan Semiconductor Manufacturing Company, is the world's largest independent chip foundry. At the same time, Intel missed the hardware boom in generative AI and faced critical hardware degradation issues in their 13th and 14th generation desktop chips. AMD took advantage of these failures. They prioritized power efficiency and system stability, avoiding the architectural defects that have recently hampered their primary competitor. Choosing AMD in 2025 is a pragmatic shift. It provides a stable path for professionals looking to avoid the specific fabrication delays and hardware degradation currently impacting high-end Intel chips. The hybrid build strategy begins by extracting the surviving hardware from the dead machine, specifically a capable RTX 4060 graphics card and several high-capacity hard drives. Incorporating these recycled parts reduced the cost of the new build by 27,000 yen compared to an inflexible pre-built alternative with similar power. These components are housed in the Antec AX90 mid-tower case, which provides the necessary airflow for modern, high-performance hardware. The physical assembly centers on the AM5 socket. In this design, the processor is pinless. Instead, a dense grid of pins is located directly on the motherboard, making the socket itself the most fragile part of the build. This motherboard layout requires a silicone grease guard. If thermal paste spills off the processor and into those pins, cleaning the socket without causing permanent damage is nearly impossible. Modern hardware is highly standardized, but the physical risks are higher than before. A single slip during assembly can now result in a catastrophic loss of the motherboard. When you press the power button for the first time, the screen often remains completely black. This is DDR5 memory training. DDR5 is the latest generation of high-speed random access memory. This training is a necessary hardware check, where the motherboard tests and optimizes the connection to the new memory sticks. You must wait for up to 10 minutes without intervention. Restarting the computer during this window will interrupt the training and likely cause a boot failure. After the system posts, the Windows 11 installer creates a barrier. It demands an active internet connection to force the creation of a Microsoft account, which blocks the setup if your new system lacks the correct network drivers. You can bypass this by pressing Shift plus F10 to open a command prompt and typing ms-cxh:"local only." This hidden command allows you to finish the installation using an offline local account. A final hurdle involves the storage drive. The Western Digital SN770 SSE has a firmware bug that causes a BSOD under heavy loads in Windows 11 version 24H2. A BSOD, or blue screen of death, is a critical error that signifies a system crash. You must update the drive's firmware immediately to prevent data corruption. Building a PC today is less about physical assembly and more about navigating these invisible firmware and software obstacles. A default Windows 11 installation consumes significant hardware resources for telemetry and background tasks. This saps the power you need for gaming and creative projects. Reclaiming that power requires unlinking and uninstalling the built-in OneDrive application. This stops the system from silently syncing local files to the cloud and frees up system memory. Maximizing performance also involves security trade-offs. Features like core isolation and virtual machine platform protect the system through virtualization, but they create processing overhead that reduces rendering speeds. Disabling them prioritize raw hardware performance. To reduce online lag, you must edit the system registry. The registry is a central database Windows uses to store low-level system settings. Modifying the network throttling index disables the limits Windows places on network bandwidth, allowing data to flow more freely. Reclaiming system resources from the operating system is a necessary final step in establishing true hardware ownership. The results of this tuning are clear in the benchmarks. The new Ryzen CPU delivered a massive 2,000-point increase in the TimeSpy processor score and achieved very comfortable readings in demanding titles like Monster Hunter Wilds. The ultimate test for a modern workstation is running generative AI locally using AMD's Amuse 3.0. Amuse 3.0 is a software tool that uses your PC's own hardware to generate images and video without needing a cloud connection. The machine generates 6-second high-quality video clips locally. This proves the Ryzen processor and the recycled graphics card are capable of rendering complex AI workloads without relying on external servers. This process transformed a dead 2016 machine into a highly efficient hybrid 2025 workstation. This build results in a machine that is deeply understood and precisely tuned. The builder maintains absolute control over the hardware and software layers, ensuring the system remains a reliable tool for their specific workload.